Okay, welcome back to the second half of the lecture. This one we will focus more on how to configure switch ports. So let's start. Oops. Okay. So before going into switch ports and what are those, we need to understand how they would function. So you know, or you have read in CE 155 about the modes of communication, right? One would be full duplex, one would be half duplex. So the full duplex communication increases the bandwidth efficiency by allowing both ends of the connection to transmit as well as receive the data at the same time, right? It's sort of, you can consider it as talking to another person on the mobile phone. You could speak as well as you could hear back. I mean, it would not be very ideal. You'd not understand what the other person is saying or what you are saying, but it's like talking to a person physically as well, that you can both speak at the same time and you can do activities. Whereas in half duplex, you'd only have unidirectional communication. You could consider an application such as the military people talking on the walkie-talkie, right? So they have this nomenclature like over and out and something like that. So when one entity stops speaking, they say over, so that the other person knows that there is the stop of communication from their side, and then they need to talk from their end. So that sort of is the half duplex. So these are the full duplex and the half duplex modes of communication. The gigabit Ethernet and 10G NIC is the network interface cards requires the full duplex connections to operate. They'd not be able to operate on the half duplex modes, whereas like the 10 Mbps and the 100 Mbps connections work on half duplex mode. Full duplex modes offer 100% of efficiency in both directions, that is transmitting as well as receiving. And we should not be having collision while we are in full duplex or while the mode of communication is full duplex. This is essentially sort of, doubling the bandwidth. For example, if you were using one line to just send 50 bits of data, and now you are using the same line to send as well as receive the 50 bits of data. So you have essentially doubled the bandwidth. Now let's see how to configure switch ports at the physical layer. For that, I mean, it would depend upon the cables really. So it depends upon what the maximum capacity of the cable is. For example, if the cable could only support 100 Mbps of data at one time, you'd not be able to use full duplex mode on that, right? So it essentially depends upon the cable, but considering that cable can operate at that given speed, you'd have two settings or two commands that we will be able to help you configure Mbps of data. Let's using the same line to send as well as receive the 50 bits of data. So you have essentially doubled the bandwidth. Now let's see how to configure switch ports at the physical layer. For that, I mean, it would depend upon the cables really. So it depends upon what the maximum capacity of the cable is. For example, if the cable could only support 100 Mbps of data at one time, you'd not be able to use full duplex mode on that, right? So it essentially depends upon the cable, but considering that cable can operate at that given speed, you'd have two settings or two commands that we will be able to help you configure the duplex settings. So the first one being duplex and the second one being speed. I'll be using packet tracer to show you this. The default setting for both the duplex and the speed in Cisco 2960 and the 3560 speed is auto. That is that they have three settings: 100, 100, 10, 100, and 1000. They either operate in half or full duplex. The 10 and 100 primarily operate or only operate in primarily operate in half duplex, whereas 1000 Mbps only operates in full duplex mode. We also use a strategy called auto negotiation. It's quite useful when you do not know the device settings, or the device settings may change, or even if you do not know the line that is connected to the other end. So you use auto negotiation. It contacts the devices, and it changes the full duplex or half duplex automatically, so that the similar sort of settings are there on the both ends. So again, when connecting to known devices such as server, it's best practice to manually set up the speed and duplex setting. But when you do not know the devices, or you do not know the configuration, or like what setting they would be operating on, you could use the auto negotiation. We'll be discussing more about that in the later half of the lecture. Again, when troubleshooting some switch port issues, it's important to check the duplex and the speed settings so that both of these devices are in the same mode, so that there's no collision, there's no packet drop, etc. Sometimes mismatched setting for duplex mode and speed can cause connectivity issues. For example, if you have very fast internet speed at one end and then the other end is not having the same speed, it could cause the connectivity issue. So all fiber optic ports, if you're using fiber optic cables, the 1000 base SX ports, they operate at one preset speed and they always work in full duplex mode. Let us now go to the next slide. For example, in this one, right, it's configuring switch ports at physical layer. So it has two fast Ethernet ports. So one is there are two switches, two end devices. This one is associated with PC1, S2 is associated with PC2. They both are in full duplex mode, or we need to configure them in a way that they are in full duplex mode and work on 100 Mbps. Right, the commands that we could do is are listed as follows. So again, if you want to take a picture on your phone, and then I'll go to packet tracer so that you can follow it correctly. I hope you have taken the picture now, so let me switch to packet tracer. So some of you have asked the question like how to go into the settings. So it's quite easy. So if you just press switch it and go to this top navigation bar, you go to CLI, you would go into the settings, right? Similarly for PC, if you press this one, this menu, pop-up menu would open up, and then if you go to the terminal and then you just select OK, you'd go to the similar settings. We'll discuss more about that in lab. Again, so we are now in the switch. So I'll not be configuring the full because we only have this one now, and given time constraint, I'll just show you how to configure this one. So again, go to the configuration mode. So this one is the command configuration T or terminal or whatever. You then the second one is that you go to this one. Did you remember like which port did we go to, or we have this mentioned here? So it is fast Ethernet 01, which we assign or which we connected to this PC1 too. So we go to that interface. For that, the command is interface fast Ethernet 0 by 1. So now we are in this fast Ethernet, this setting, right? Then what did we need to do? We need to mention the duplex mode. So the command was duplex. So if you're not very sure like what modes are there, if you just press question mark. So I just pressed question mark and it gave me three options. So one is auto, which is the default. It enables automatic duplex configuration. Second one is full. So it will force the full duplex, and then this half, it will force the half duplex. Here our target was to configure a full duplex. So we mentioned full. Press enter. You could see that the status changed to down. Okay, that's okay. And then after that, we need to check or configure the speed. So again, if you press question mark after speed, you know that these are three modes. So one is 10, 100, sorry, and the third one is auto. If this switch is updated, or if we have 3560 switch, you'd also see 1000 as well. So speed was to configure 100, right? Did we need to do it? No. And then end. So if you want to reflect these changing onto the very start of your switch, so you just copy the running configuration to startup configuration. Press enter because we do not want to change the name. So done, right? If you want to see whether these are reflected, you just show running configuration. Here you could see in interface fast Ethernet 01, we have duplex as full and speed as 100 as we just did, right? Okay, everything else is as it should be. That's all right. We did mention about automatic configuration, right? So for that, there's this interface crossover called Auto MDIX. It's MDIX stand for Medium Dependent Interface Crossover. So when this auto MDIX is enabled, the switch interface automatically detects the required cable connection, that is the straight through or the crossover. So if you remember the concepts from introduction to networks, that is CE155, you would know the functionality of straight through cable as well as the crossover cable. So the straight through cable works between, say, different devices. So if you want to connect a switch to a PC or a switch to a router, uh, or a router to a PC, like that, you use the straight through cable. And when do you use the crossover? When you need to connect the likewise devices, such as a switch to a switch, a router to a router, a PC to a PC, then you use the crossover file, right? When connecting to switches without this feature, so if you do not have these features, you need to make sure that you have correct cabling done. That is straight through cable for like devices and crossover cable for the other devices. But when this auto MDIX is enabled, you do not have to worry about the cabling. So it might be, so either cable type can be used to connect any sort of devices, because auto MDIX automatically adjusts uh, the functionality of the cable, right? So again, it is to note that let's go over this point as well. On newer Cisco switches, the MDIX automatic interface configuration mode enables this feature. So you just need to do MDIX auto and it will automatically enable the Cisco switch to focus on the MDIX. But when using an auto MDX on interface, the interface speed and duplex must be auto. Yeah, this is an important point. As we set the duplex to full and speed to say 100, but if we have used the MDIX auto mode, then those duplex and speed should also be set to auto. That's when the switch can automatically shift according to the required setting. But if you have manually interface say speed 100 and then your MDIX setting is auto, then it would not work. It would give problems. So to note is that MDAX is enabled by default on 2960 and 3560, but it's not available on the older versions of the Catalyst 2950. And 3550 switches. Okay. To examine the auto MDAX setting for a very specific interface, you could do is show controllers Ethernet controller command with a physical keyword. I mean, this would not work on the 12.2 Cisco 2960, so I'd not be able to show you that. But again, in nutshell, auto MDIX is used when you do not want to care about any of the cable that you use. It will automatically adjust the port to see the similar setting on both ends. Again, after this one, we have switch verification commands. Like if we want to troubleshoot some issues, or if we want to dig deep on what settings have been configured on different interfaces or in different devices, you could use these commands. You might have done already, or you should actually know them already from your introduction to networks. So the very first one is show interfaces. So it will display the interface status and the configuration. Let's go over it. So you have switch. If you go to show interfaces, so I have run the command show interfaces. I think the font size could be actually less, right? Or make it big. Are you able to see that actually? I'm not sure. Let's see how to increase the font size. Okay, zoom in. No, that's zooming in there. We need to increase the font size. Can someone of from you in chat suggest? Otherwise, I'll check it. If I enter full screen, I think, is it better? I don't think so. Should be somewhere here. Options, preferences. So options, there's no preferences in here. Or in here, you're saying. Okay. Oh, yeah. So font, command line, say 14 again. Face 14. Apply. I hope it's better now. Yeah, I think now it would be right. Yeah, thank you for suggesting. So where were we? We were to, okay, yeah, we were to see the show interfaces, right? So let me again go show interfaces. So show interfaces is the command. If I enter, you'd see, so this is the command I issued. So the fast internet is down, line is down. This hardware address is this. The bandwidth is this one. The delay is this. Reliability is this one, and it is full duplex, 100 Mbps. So oh, okay. So similarly for other interfaces, so this is fast internet 02, which we have not set. Again for fast internet 03, so it will be showing for every interface. Okay. The second one is show startup configuration that we have already seen. So that when we started off the switch, and then we also saw this show running configuration that had the running command. Let's see this show flash. So flash would show you the directory of flash where the configuration text is, its read write permissions. It is again read write permissions to have this one, the image file. Then there's show version. I think I showed you this show version before. Again, let's go over it. So it will show you the basic MAC address, all of the information, the motherboard revision number, again, whatever information is associated with the switch. The basic thing we could do is which version of switch it is. It is 12.2. It shows the configuration register as well. So all of these could be seen from show version. Show history again. Yeah, if I issue show history, or show hist for short, you should see what commands I issued. It has it has a log of 10 commands. In the later part of the lecture, we will see how we can increase this buffer. The show IP interface is again similar command. It shows the VLAN interface. So VLAN 1 is down, VLAN 99 is down, which we configured. It has maximum MTU size is 1500 bytes. So all other, oh yeah, one important is that when you'll be using routing and switching, you'll be wanting to know what MAC addresses are there in the routing table. So for that, the command is show MAC address table. So you see that this is empty for now, but when your devices are connected, when they are sending the packets using this switch, this table would be populated. That's about it for this one. Again, verify port configuration. So you could use show running configuration. We have already seen what IP addresses it would have, and it will have, we have not configured IPv6, so ours did not show IPv6. Was showing IPv4 default gateway as well as IPv4 address along with subnet mask. So when we should show interfaces, actually, this is also interesting. So if we use show interfaces, but again, put just one line, which we configured, it will give you the details for only that Ethernet line. So this did not give the output for all the interfaces, right? It is less hassle for us. So if you just need to understand or debug or troubleshoot one of the interfaces that you feel the problem is, you could use this command show interfaces. That is, after that you could put what interface you would want to check, and then it will give you the output for that interface only. So these are issued when you want to access the network layer issues. But what are those issues? We have already discussed show interface command, so this is done. But let's discuss more about the network issues that we could face. So when we use the show interface fast Ethernet, you see in this output you have the errors. You have 0 runs, 0 giants, 3 input errors, 3 CRCs, 8 output errors in total, 1790 collisions, 10 interface resets, 235 late collisions. So all this gives you an idea of what's happening around in the line. Let's see whether there were any errors. So in this one, you could see that there were no input error, no CRC, no frames. But when you would be sending the data, the errors could come. Considering this scenario, we consider that there were these many errors. So let's see what these errors are for. So the input error showed total number of input error. It included runs, giants, no buffer, cyclic redundancies check errors, frame, overrun, and ignored count. So it was the total count of all these errors. Well, let's individually see what these errors are. So runs are the packets that are discarded because their packet size was smaller than the minimum packet size. So as the minimum packet size that could be transmitted over a network, say if it is 64 bytes. So if a packet is below 64 bytes, it would be considered as a runt. Giants, on the other hand, would be the packets that exceed the maximum MTU size, like maximum transmittable unit. So the maximum transmittable unit is 1518 bytes. So any packet that is of size greater than this would be discarded, and it is considered as a giant. CRC errors are the errors when we are calculating checksum. They are the errors that do not match. So if there are two CRC codes that do not match, the input CRC and output CRC, so it would count as an error. So these are the CRC errors. Then the output errors are the sum of all errors that prevented the final transmission of the datagrams or the PDUs out of the interface. The collisions are the number of messages that needs to be retransmitted because a collision happened and they would not be able to reach the destination. Late collisions is again a different concept. It's basically a collision that occurs after 512 bits of the frame have been transmitted. So a late collision is that, some part of the frame has been already transmitted, but some part was already under transmission and then it collided. In full duplex, we would not want to see the collisions, or the collisions would not occur in full duplex. But if you see the collision in full duplex, then it means that there is some problem and you need to examine. So as we mentioned that we check this, yeah, so let's see what are the causes of these. So runts and giants are basically caused by malfunctioning NICs. So when your network interface card is malfunctioning, then it would send a packet that's too large or it would send a packet that's too small. The CRC errors usually show the cable connections or the error in the media. So if you have any electrical interface or any other EMI, and then the CRC errors tend to increase. So if you, upon checking, if you see that there are many CRC errors, you might want to inspect the cable. You might want to see whether it has loose connections, or whether there's some other electrical media present around it, which needs to be eliminated so as to decrease the noise. Right? So these are mostly used for troubleshooting. Then the output errors are like collision. We have already discussed, they happen in the half duplex. They are very common in half duplex, but they should not be seen in the full duplex. Late collision we have already seen. So yeah, the one of the causes of late duplex is late collision is the duplex misconfiguration. So if one is set for auto, one is set for full, then you might see late collisions happening. Let's see how to troubleshoot the network access layer issues. So you perform a show interface command, and it will show your interface settings. So if an interface is the interface up, you'll see. If it is not up, you then verify your cables, you check the connections, and then you verify whether the port ends or the speed or the duplex settings are correct. If it was up, and then you'll check like, are there any other indications of noise or EMI from the CRC errors or any other errors. You check on the settings, you reconfigure your switch according to that, and if the problem is solved, well and good. If not, then you document what you did and what still the problem is, and then escalate the issue. So just to test your knowledge, which command will provide information about status of all the interfaces, including giants, runs, collision interface? I'll give you say 10 seconds if you put it in the chat. No, just one answer, and that's it's not a, yeah, it's show interface. It's not running config. So running config would just give you the running configuration file. History would give you all the list of commands that you issued. Uh, Show interfaces is the command that would give you the details of all the giants, runs, collision, and interfaces. Right? Let's check the secure remote access. So the SSH and the telnet issues we would be understanding in that. So what's a telnet operation? Telnet is a terminal emulation software. It's used to connect for remote connectivity, but it's not very secure. It uses TCP port 23. It is an older protocol that uses unsecure plain text transmission for both the login and the authentication. So if someone has a packet sniffing software in place, such as Wireshark, they could sniff your packets, and from the telnet data, PDU or telnet data, they can sniff your username as well as password. So this is not very secure. So you could see that in this Wireshark, they have analyzed this telnet data packet. They analyzed this frame, and then the username and the password were unearthed. So we would not want to use this weak sort of uh, sending mechanism to send the login information, because it's very sensitive, right? So what's the alternative? The alternative is using the SSH protocol. It's the secure shell protocol. It uses TCP port 22, and it sends the data while like after sorry, after encryption. So SSH replaces telnet for management connections. It provides security for remote connection by providing strong encryption. So you could see in this Wireshark image or capture, you could see that the packet sniffer did sniff the packet and did compute whatever is required, but you could see that it's all encrypted. You'd not be able to make sense out of it, that what's the username, what's the password. So telnet is not a very secure version, whereas SSH is the alternate and a good option while sending the sensitive information. And we will mostly be configuring our switches and routers to operate on the SSH mode. Again, we did mention the show version. So it needs, if you want to verify the switch, whether the switch supports SSH, you issue the show version command. And if it gives you sort of K9, it's the cryptographic primitive. If it gives you K9, and it means that it would support the SSH. The present version of the Cisco 2960 switch, let me show you, show version. It's the LAN base M, but it still provides some sort of capabilities for SSH. It's not the updated one, but it does also provide. But if you just see K9 in the as a part of your file name, then it would definitely provide the support. So how do we configure SSH? Given the time, okay, we'll do that in lab. Otherwise, I was to show you in the packet tracer, or maybe I could just one. Now let's do it in the lab only. So what you need to do is you first need to verify the SSH support by issuing the show IP SSH command. Let me show this only. So show IP SSH, it says SSH is disabled, but the version 1.99 is present. So if you want to use it, you need to create RSA keys that would be at least 768 bit size to enable the SSH version 2. So we found that it supports the SSH by issuing the command show IP SSH. Then we need to configure the IP domain. You might have done this in C155, and we'll also do in lab. So you issue the IP domain name, whatever, for example, ccna.com. So you issue an IP domain name command, and then the third one is to generate the RSA key pair. To generate the RSA key pair, the command is crypto key generate. It's not listed, so it's not it's a crypto key generate RSA. Let's try to see this. So you also need to configure host name, because it would not work on default host name. Oops. Need to go to configuration mode. Host name say S1. You see that now the switch config has changed to S1 config. Issue a IP domain name ccna.com, then crypto key generate RSA, and then it asks for how many bits. So for example, 1024, sorry. It now says that generating bits and key will be non-exportable. So we have now did the RSA key pairing. So if you want to delete a key pair, if you want to regenerate something, the command is crypto key 0 is a RSA. Then you configure the user authentication so that you implement the SSH. But before the SSH is the last part. So user authentication is that you create your username and a password. So for example, username admin, and pass for that is secret, say CCNA. Okay, SSH5 enabled has been enabled. So once you do this, the SSH is enabled. Then you configure the VT management line. I'll so briefly discuss. So line VTY 0 to 15, and this one transport input SSH. So this one shows that all the data that would be coming into this one should be the SSH. And then you also do login local. You would know that what it is used for. So it's used for those of you who has not attended C155, it's used to that you use this information that is stored locally for logging into the lines, then exit. So this is what we have done. So if you want to enable SSH version 2, because it supports both 1 and 2, so you need to issue a command. It's called IPSSH version 2. Before that, we seen that there was 1.99, right? Oh, sorry, I need to end. So IPSSH. So before that, you saw that it was 1.99. Now we have changed it to IP version 2. So this one is now secured. So if your packet sniffer would operate, it would not be able to sniff out your login information. So how to check how to verify whether SSH is operational? You need to use the third party tools such as putty. I don't have it in here, or we don't have actual switches, so I'll just show you how it works on the next slide. So if you have this putty configuration and you have a switch, you put that switch host name in here, port would be 22 and say SSH. Then it would ask you the login information, and the first you need to provide login as admin, since we put admin as the username and password was CCNA. Once you put CCNA, you could have that enable option, and then if you put the enable password in here, you'd go to the configuration mode. So this is how you could use you could verify whether SSH is operational, and how to use third party to configure your SSH. Again, we use the show IP SSH. If we just use show SSH, it would show all the connection. There's a SSH packet tracer activity involved in this, so please try to do that from the Netcad. It should be very easy if you have seen this. Yeah, a little time to test your knowledge again. So which TCP port is used by Telnet? You can again mention your answers in the chat. Yeah, it would be the port 23, or option C is right. Again, given the time, I think I did all the packet tracer activities today because I thought that you might have rusty concepts about CE155, or you might forgot what it was. But from now on, we will be picking up the pace from the next lecture. So let's see how to configure basic router settings. We did see from packet tracer how to configure switch. A router is something similar. So for example, if I go to network devices,